I'm going to talk to you about a peculiar process called radioactive process or radioactive emission. So let me just choose one example. I'm going to choose a very familiar example called radium. This radium this radium nucleus. I'm going to talk to you about radium nucleus. This radium nucleus has 226 nucleons. Nucleons meaning protons and neutrons, out of which 88 are protons. So the atomic number of radium is 88. Somehow the radium is not so happy about this number 226. It feels that there are too many. So it is slightly experiencing discomfort with too many nucleons inside. Too many nucleons inside. So it wants to throw away some of the nucleons. So what this radium does is effectively throwing away a small portion of it. In that small portion, it throws away two things. One is two protons it throws away, and two neutrons together it throws away. So two protons and two neutrons. That means this is nothing but the nucleus of helium, which we famously called alpha particle. Alpha particle. So after emitting this alpha particle, after throwing away this alpha particle, this radium is somehow happy with it, but the problem is the color changes. So far this fellow was called radium. Now this fellow is going to be called someone else. Why? Because I'm going to call him radon, because the radium had 88 protons. As long as 88 protons are there, he is still called radium. Now this fellow has only 86 protons. 86 proton does not belong to radium, whereas it belongs to radon. So after experiencing discomfort by throwing away alpha particle, radium converts itself into radon. Now total of 4 particles are gone. So 226 becomes 222. Actually, for this to happen, the nature will take its time. The nature is going to take its time. The nature is going to take its deciding time. Let me call it deciding time, which we are going to call after, we are going to name it after. So the nature is going to decide when this radium is going to get more uncomfortable, and by emitting an alpha particle to convert itself into radon. So the species has totally changed from radium to radon. So it is converting itself into from one element to another element. So this process we somehow called decay. Decay means it does not vanish. In this decay, one species becomes another species. Suppose if you call the original species as X, he becomes a new species Y. In radioactive decay, one species becomes another species by emitting a particle. It can be an alpha particle, as I said here. Sometimes it can be a beta particle. Only by emitting an alpha particle and beta particle, a species changes from one to another. This process we call decay. This we used to be calling them radiations. By emitting a even though we know these two are particles right now, we used to be calling them radiations. So by emitting alpha or beta radiations, some nuclei convert themselves into another nuclei. We call it radioactive nuclei. So that's why they are called radioactive decay. Okay, so they are converting. But now when an element is going to get uncomfortable, so what is the trick behind that? So this trick is going to be played by nature. And suppose if there are two radium nuclei, and in that two radium nuclei, let me call it two radium nuclei, and the nature will take its own time. The nature will take its own deciding time to convert which one is going to experience more discomfort. The nature is going to decide. If there are two, the nature will take so much of time to allow one to become radon. This is radon actually. So the other to become the other to be as it is. So you know what time it will take. This radium stays as radium. This radium becomes radon. So this is what the process. Okay, it is still there. It still has 226. It has to live with it, whereas this has only 222 and it is still having this. Okay, you know what is the deciding time for this? It will take 1600 years. Suppose, what if the thing is different? Suppose it has 4. If it has 4, within it will also take the same amount of deciding time to let this way. So within the same amount of 1600 years, it is allowing, one second, within the same amount of 1600 years, it is allowing 2 of the nuclei to convert themselves. What if you have one full plate of radium, within the same 1600 years, it will make half the plate radium, remaining half the plate radon, remaining half the plate radon, with 222 numbers and 86, and this one is 226 number with 88. So this process, so now let us name it. Suppose this number is 1 and 2. Whether this after 1600 years, which person is going to become radon, we can't be sure. It is only decided by statistics. So it is only, nature decides that statistically. You cannot say in this plate the above half is going to stay as it is, the below half is going to convert themselves into radon. You just can't say that. If there are 1 million, 500,000 will be here, 500,000 will be here. You can't decide on which one is converting itself into radon or something. This process, the radioactive decay process, we are going to call it radioactive decay process. In this radioactive decay process, the nuclei is not decaying and vanishing. It is converting one into another. This radioactive decay process is a statistical process. And this statistical process takes a deciding time, after which it is going to convert half of it into another. So that deciding time in that radioactive process, we are going to call it as half-life, because within that time half of them are becoming something else, half of them are decaying and becoming something else. So the nature's deciding time to convert one full sample into half sample into something else, half sample remains as it is. It's called half-life. Suppose you start with 1 million to become 500,000 in the same half-life, and in the same half-life, let me call the half-life as t half. After t half, it becomes 500,000. After one more t half, it becomes 1/4 of a million, and after then another t half, it becomes 1/8 of a 500,000, and so on. So you see, one nuclei that escapes every decay. After so many iterations, you are going to finally have only 2 nuclei, out of which one decays, the remaining one rests. So this one that escapes all the decay literally has infinite lifetime. And at this point, there is going to be one nuclei that immediately converts itself into radon. So that has 0 lifetime. So if you take one platter of sample, out of which one nucleus is going to have 0 lifetime, one nucleus has zero lifetime. The other nucleus, the one that escapes up till the last iteration, that one that is going to decay at last, has infinite lifetime. So we have no reason, it is literally no reason to talk about. So I'll just take the previous board I haven't cleared, just a minute. Okay, so this one you see, one nucleus has, the first nucleus that decays has zero lifetime. The last nucleus that is going to decay has infinite lifetime. There is no point in talking about lifetime of a nucleus in a radioactive sample. You can only talk about the average lifetime. You can only talk about average lifetime of a radioactive sample together. Suppose if we had some 10 grams of radium some 3200 years, by now we will be having only 5 grams and then 2.5 grams. Suppose in all the earth put together, if we had 20 grams of radium, then 3200 years back we must have been having 80 grams. So based on the amount of sample present, the amount of radioactive nuclei present, you can also find out the time. That is called radioactive dating. So this is just an introduction. This is just an introductory video. In the subsequent videos, we'll talk about the law that it follows and how does it decay, etc. We'll talk about it. So know that if for a radioactive or the nucleus that is active, we call it radioactive. There is no point in talking about the lifetime of a nucleus. We can only talk about average lifetime. Since there is no point in talking about lifetime, we are going to only talk about half-life, not the full life. So in the subsequent videos, we'll be talking about what is average lifetime, then what is the half-life, and what are the factors it involves, etc.